Welcome to my video on measuring the density of a copper bar. Before we get into that, actually doing the measurement, we're going to talk a little bit about what is density. Density equals rho is the Greek symbol for density typically, mass divided by volume. So in the SI or metric system, we're talking about grams per cubic centimeter. That's what we're going to be dealing with today in this video. Or it could be grams per milliliter for liquids or kilograms per cubic meter. That would be what we see a lot in engineering and physics. The English units of density are going to be pounds per cubic foot or pounds per gallon. And then here's some conversions. The one we'd be interested here is 1 gram per cubic centimeter is equal to 1,000 kilograms per cubic meter. This is the video where I'm going to go over what I did here. And this is the actual measurements. I'll kind of narrate this as I go along so you can see what I did. So there's my gram scale, and then there's the, that's a gram scale. That's the bar and measurement. There's my vernier caliper. So let's get this started. So first of all, I have the gram scale. I've checked that against other standards, so I feel it's pretty accurate gram scale. I measured my and it came out to 231.57 grams is what it measured out. So I feel that's a good number. Now, the next step was to measure the dimensions of the copper bar using a vernier caliper. I made sure it was zeroed out properly. We're on the millimeter scale in the bar. And first of all, measured the thickness of it, and that turned out to be 6.34 millimeters. So next I'm going to measure the width, and that turned out to be 50.58 millimeters. And then my last measurement is going to be the length, and put it that in there. And there's always a little error associated with these measurements because you never know exactly when it's all perpendicular. That turned out to be 83.48 millimeters. So there's the measurements we needed to do the calculations. So here's a result of a summary of the results of the measurements. The mass is 231.57 grams thickness. We convert that to centimeters, 0.34 centimeters, width 5.58 centimeters, and the length is 8.348 centimeters. Now there's one little wrinkle in this. If you notice, the edges are semicircular. That's going to affect the volume. So that's what I need to do next, is figure out how to get rid of that or correct that calculation. So basically what we've got here, here's the edge view of the bar. It's flat with two semicircles at the end. So really the way we can do this is measure a full length bar by the full width, and then subtract off the rod, essentially. That is the difference right here. So that's what we're going to do. So the thickness of the total bar, basically this right here, thickness, width, length, that's 26.77 cubic centimeters, multiplying the thickness, the width, and the length together. That's what we get. Now what we have to do next is we have to subtract off that semicircular ends. So that's going to make, so each of end is half a cylinder. So the two halves of cylinders equal one full cylinder. So the radius is going to be the thickness, 0.634 centimeters, divided by 2. That's 0.317 centimeters. So the height is going to be the full length of the bar, which is 8.348 centimeters. So now using our volume of a cylinder calculation, so the volume is pi r squared times the height. That's approximation for pi, 3.1416. That was our radius, 0.317 centimeters, and then that was our length. So that tells us the volume of the bar that we need to subtract is approximately 2.63 centimeters. So this is going to give us a corrected volume. We took that total volume we measured, just considering the bar just be a perfectly rectangular solid, 26.77 centimeters cubed. We subtract off the 2.63, which is the volume of the bar. Now, so that gives us a revised volume of 24.14 cubic centimeters. So our density calculation is mass divided by volume. The mass, we figured out, was 231.57 grams. We divide that by this revised volume number, 24.14 cubic centimeters. That gives us a density of 9.59 grams per cubic centimeters. Now, with every time we do a measurement, we have to calculate that against the reality of the actual measurement. So we know the density of copper, and it's going to turn out to be this 8.96 grams per cubic centimeter is what it's going to be. So what we do is we calculate the percent error, and that's a measured minus the accepted divided by the accepted times the 100%. So in our calculation here, that 9.59 was our measured density minus the textbook value of 8.96 divided by 8.96 times 100. So the difference here is 0.63 divided by 8.96 times 100. So the units go away. It's grams on top, or grams per cubic centimeter on the top divided by grams per cubic centimeter on the bottom. So it's dimensionless. So we get a 7% error, which to me seemed a little high. And I think I've got some a discussion on that as the sources of error. Because anytime we do a measurement, we need to understand what's going on here. So first of all, it could be imperfect machining. This may not be exactly semicircular on the edges of the bar. It could have been some other partially elliptical. The surfaces are going to be contaminated with dirt. They look clean, but there's always this layer of oxidation that forms on every piece of copper. The bar may be not quite pure copper. I didn't do some type of chemical analysis, but it probably is very close to pure. And then there could be instrument measurement errors. I think that's pretty small. I think all of these are real small errors right here. I think the main problem is the human error, especially with the vernier calculator. What I did was the calipers. I measured that on 2 or 3 different times and got slightly different numbers each time. So I think my main 2 sources of error is the human error in reading the bar. Sometimes you don't get that exactly perpendicular with the caliper. And then this may not be a perfectly semicircular edge. Well, I hope you got something out of this and learned a little bit of how to measure the density of copper. If you did, give me a like, thumbs up, subscribe to my channel, and thank you for watching.